Hi everyone! In this video, I'm going to show you how to use sine, cosine, and tangent backwards, essentially. So instead of going from an angle to a side length or a slope, we're going to go from the side length or the slope and work backwards and figure out our possible angles we could have used within 0 to 360 degrees generally to get there. So, just a quick recap. Let's say we're trying to do sine of 210 degrees. Right? So the way we do this is we sketch our quadrants, we label our 180 degrees, which is over here, and 210 degrees is 180 degrees plus 30 degrees. So we need to do 30 degrees past 180 to make our triangle down here. And so this is 30 degrees in here, and this is 210 degrees. And since we care about the sine, we want the vertical piece. And the vertical piece in this case is negative because it's going down. And since it's the short length of our 30 degree, 60 degree triangle, it is negative 1/2. Okay, so sine of 210 is, negative 1/2. Okay, cool. Now, does this mean necessarily then that we can go backwards from negative 1/2 and figure out that it's 210 degrees? Right? And that's the idea of an inverse operation. So in general, if you've got some sort of function, f of x, right? A function is something that takes x values as input and gives you y values as output. Right? That's sort of one way of defining a function. What that means is then if you want to go backwards, take from your y value and get your x value out of your function, you need some sort of reverse function. And our notation for a reverse function is f minus 1 of x. And this is the inverse function. And f of x, of course, is just our basic function. So can you undo sine, cosine, and tangent? And sure you can. Ish. And we'll talk about the ish in a second. But just like we have this minus 1 notation for inverse functions in general, the inverse of sine is, so sine of theta, I guess, because sine should always have an angle, is sine inverse of, usually it's a y value, right? Because sine gives you the y value of a function. So sine theta gives you y, and sine inverse of y gives you theta. Okay? So this is our function, and this is our inverse function. Okay? Similarly, for cosine, cos of an angle gives you your x value. So cos inverse of your x value should give you an angle. And tangent of theta, what does tangent of theta give you? Well, tangent of theta gives you a slope. So then tan inverse of your slope should give you your angle. Okay, so that's the big idea. So if I tell you the y coordinate of of the point on a terminal arm, which is the sine of the angle, then we should be able to work backwards to figure out our angle, theoretically. But let's go back to our first example. Is this the only triangle that has negative 1/2 for its height? There's also negative 1/2 over here, right? So we could also have, this is 360 degrees. 30 degrees back from 360 makes this 330 degrees. So that tells us that if we have sine inverse of negative 1/2, right? So this is the y value. Then there's actually two possible values, 210 degrees or 330 degrees. And in fact, because of rotations around the unit circle, there's actually infinitely many, right? So instead of like 210 degrees would be if we just went like straight like this. But we could also do a full rotation all the way around the circle, 360 degrees plus 210, right? So you could also add 360 degrees to this as many times as you want and still get an angle that gives you negative 1/2 for your sine. And same thing here. You could you could subtract as well. So plus or minus 360 degrees as many times as you want on your 330 degrees as well. And so this is sort of one of the wrinkles of inverse trig functions. Trig functions aren't actually what are called invertible functions because you aren't only getting one value out of them. You're always within 0 to 360 degrees going to get two values. Well, almost always. There's a couple exceptions. But you're almost always going to get two values between 0 and 360 degrees. And you're actually going to get infinitely many values if you count additional rotations of 360 degrees forwards or backwards around the circle, right? You can go around as many times as you want and end up here. So the way your calculator handles this, by the way, is it only gives you sine inverse values on the right half of the circle. So if you define sine inverse just from -1 to +1 on the sine, then you will get between 90 degrees, 0 degrees is here, and they do -90 degrees. So you can try this on your calculator. If you do sine inverse of -1/2, your calculator will actually tell you that it is -30 degrees. And it won't tell you at all about the other answer over here on the left. The whole left side of the circle is ignored. Okay, so this is how your calculator, that's the calculator's, this is the output, so this is the range of sine inverse. And similarly for cosine, the way calculators do it is they only give you the top half of the circle. So this is 180 degrees, and this is 0 degrees. And it just ignores the whole bottom half of the circle. So this is the range of cos inverse in your calculator. So this means you actually can't really use your calculator for this. You actually need to understand what sine and cosine mean in the full 360-degree circle so that you can get the two possible values out of it. And that's what makes this sort of tricky. And we'll talk about tangent in a second, but tangent is similar with slope. So let's actually jump in and try an example. Let's do cos this time. Let's do cos inverse of, let's do -√2/2. So this is what we need to figure out. Where is -√2/2 as what? Since this is cosine, that is the x value, right? Because cosine gives you the x value in your unit circle. So what we're going to do is we're going to draw our coordinates, and we're going to label -√2/2. So what are our possible triangles that have -√2/2 as its x-coordinate? We get one triangle up here, and we get the other triangle down here. And since it's √2/2, I know these are both my 45-degree triangles, right? So that's 45 degrees in here, and that's 45 degrees in here. And they're both coming from 180 because the negative sign is on the left. And so this means that this is 180 minus 45, 135 degrees, or 180 plus 45, which is 225 degrees. So this equals, or I should say, let's make this theta equals. So we can actually label what we're talking about. So then theta equals 135 degrees or 225 degrees in the range of 0 to 360 degrees. Now I'm not going to write that every time. Sometimes that's written in a question. We're going to just assume that it's within 0 to 360 degrees, because if you add the plus or minus 360 degrees, you can have infinitely many possibilities. Okay, so there we go. So those are the possible values of theta that would give you -√2/2. And there's two of them. Okay, let's try one where there's only one example. Let's do sine inverse of +1. Okay, so +1 is where as a y value, right? Because this is sine, +1 is a y value. So if we sketch our Cartesian grid, a y value of 1 is right here. So that's your positive 1. And so that is your point that is straight up, which is at 90 degrees. And in this case, there is only one possible value. Sine inverse of positive 1 is 90 degrees. And that's going to be true of the point at the top of the circle for sine, the bottom of the circle for sine, the far right for cosine, and the far left for cosine. Okay, let's try sine of 0. Is sine of 0 going to be the same thing? I mean, maybe sine of 0 is like one of your 1, 0 points or 0, 1 points. So let's see if we can figure this out. So theta equals sine inverse of 0. So we will sketch our grid. Where is your y value equal to 0? Well, there's 2 points. There's a point here, and there's a point here. Well, actually, I guess y equals 0 is here. And then if you think in terms of your unit circle, it goes through either at negative 1 on the x or positive 1 on the x, which means that there's actually 3 possibilities, I guess. You're going to allow 0 degrees and 360 degrees and 180 degrees, then you can have theta equals 0 degrees, 180 degrees, or 360 degrees. And those are all the possibilities between 0 and 360 degrees inclusive. Okay, so you guys seeing how this works? Let's try another one that's, let's do a 60-degree triangle because we haven't done one of those yet. And let's do, I guess it's cosine's turn. So let's say theta equals cos inverse of, I think we did negative last time, so let's do positive this time. And we want it to be root 3 over 2. Oh no, I said I wanted positive a half. I said I wanted a 60-degree triangle. Whoops. Okay, so cos of a half. Cos inverse of a half, I should say. So a half is the x value, of course, because this is cosine. So I need to go out a short length from my y-axis in the positive direction, which means that there are 2 possible triangles. I can get the tall, skinny triangle up here, or I can get the tall, skinny triangle down here. Those are the 2 triangles that have a small x value. And these are both 60 degrees away from our axis. And our axis on one side is 0 degrees, and working backwards, we want to do it from 360 degrees. So this is 300 degrees because it's 360 minus 60, and 0 plus 60 is just 60 degrees. So this tells us that theta is 60 degrees or 300 degrees. All right, so this is basically the same thing we did before, except, I mean, we're doing the inverse operation, so it's the exact opposite order of steps. You start with your side length, you work with your side length to figure out your 2 possible triangles, generally, and then from your 2 possible triangles, you can then figure out your angle. So let's talk about tangent. So tangent is a slope. So let's say we have tan inverse of negative 1. Well, where is our slope negative 1? Negative 1 means it's going down and to the right at a 45-degree angle. So down and to the right at a 45-degree angle is like this. And that's your slope of negative 1. And so this is going to be your 45-degree triangle. So this is 135 degrees up here, and this is 360 minus 45 is 315 degrees down here. So I also forgot to label it again. Let's call it theta again. So that means that theta is 135 degrees or 315 degrees. Okay, let's try. Let's do tangent. I'll remember the theta equals this time. So theta equals tan inverse of, let's do root 3. So if you recall from tangent, there are sort of three special values, I guess, for our 30, our 45, and our 60 degree. And our 3 slopes are going to be our 45-degree slope, which is 1. It's going to be less than 1, or it's going to be more than 1. And the way you get a less than 1, right, is when your sine is a half and your cos is root 3 over 2. So the slope of this one is your rise is 1 over root 3, which you rationalize to root 3 over 3. So this is your small slope. And this one here has a root 3 over 2 for the rise, or it's a tall sine, because this is our 60 degree, and our cosine is short, it's the small side, because it's the 60-degree triangle. So then the slope of this one is root 3 over 1 doesn't matter. So this is just root 3. So root 3 is your big slope. Right? So you either have a small slope, a big slope, or a 1 slope. So this is a big slope. Root 3 is roughly 1.73205 if you're a huge math nerd like me and you've got it memorized. So 1.73205 is steeper than 1. So it's going to go up here. And also, the thing with tangent is you always go exactly the opposite side of the circle as well, because either way it's the exact same slope. So the tall skinny thing is 60 degrees. And then 60 degrees here is 180 plus 60 is 240 degrees. So this tells us that theta is 60 degrees or 240 degrees. Similarly, if we have theta equals tan inverse of, let's do negative this time, I guess, negative root 3 over 3. Well, root 3 is 1.73205. 1 point whatever divided by 3 is going to be less than 1. So this is going to be a shallow negative slope. A shallow negative slope looks something like this. And that's really all I need to know, because just from looking at it, I can tell that this is 30 degrees. So 30 degrees back from 360 is 330. 30 degrees back from 180 is 150 degrees. So theta equals 150 degrees or 330 degrees. The only other ones would then be undefined or 0. I'm not even sure if you'd actually ever see theta equals tan inverse of undefined. Like that doesn't even make any sense because it's undefined. So I don't think you'll ever actually see this. So let's just ignore that example and instead do theta equals tan inverse of 0. Right? Because you can have a 0 slope. A 0 slope is, well, a 0 slope is horizontal. So that's just your 0 or your 180. So theta equals 0 degrees or 180 degrees. Okay, and that's how you work backwards, doing your inverse, sine, cosine, or tangent to find the two possible angles within 0 to 360 degrees.